What is the atomic mass of an element? Okay, sometimes atomic mass is called average atomic mass. And this average atomic mass is a weighted average of all the natural isotopes of that element. Okay, so how do we calculate average atomic mass, and what is this weighted average? So I'm going to give you an example of weighted average. So in this class, 55% of your grade is tests, and 25% of the grade counts for labs, and 10% of the grade is for quizzes, and 10% of your grade is for homework. Okay, so now let's say on your homework, you're getting 100%. You've got all your homework turned in. On your quizzes, you're getting 90%. Your labs, 80%. And your tests, 70%. Okay, how would I find the regular average of all of these? Well, you'd add up 70, 80, 90, and 100, and you'd divide by 4, and you'd say, my average is an 85%. Now, this is for like a regular average. But what if you had a weighted average? What if test count is a lot more? Well, now you have to go back and calculate differently. So for a weighted average, what you would do is you would say, okay, 55% out of 100% of my grade are tests. And I'm going to multiply that weight by my score. My score is 70 or 70% on my tests. And I'm going to come up with a subtotal, which is 38.5. And then I'm going to say 25% of my grade out of 100% is labs. And right now I'm getting an 80 on labs. And 80% is my average on labs. So I take 25 divided by 100 and multiply it by 80 and get 20. On my quizzes, I'm getting a 90%, but 10% of my grade counts for quizzes. So 10% out of 100% of my grade is quizzes. I multiply that by 90, and I get 9. And then 10% of my grade out of 100% is homework. I multiply that by my score, which is 100%, and I get 10. And then if I average all of these subtotals together, not average, if I add all these subtotals together, so 9 plus 10 is 19, plus 20 is 39, plus 38.5 is 77.5. So this would be my grade in this chemistry class if these were my scores on my tests, labs, quizzes, and homework. Which is different than if you took a straight average of this and took 70 plus 80 plus 90 plus 100 and divided by 4, then you would get an 85%. So you do not want to do this when you're calculating your average atomic mass. You want to do the weighted average. Now we're going to use the same process to find the average atomic mass of carbon. As you know, carbon has 3 different types of isotopes. It has carbon-12, carbon-13, and carbon-14. Now, in nature, if you had 10,000 carbon atoms, 9,889 of them would be, so 9,889 out of 10,000 would be carbon-12 atoms, and 110 out of 10,000 would be carbon-13 atoms, and 1 out of 10,000 would be carbon-14 atoms. So the percent in nature, there's way more carbon-12 in nature than carbon-13 or carbon-14. So now, how do you figure out the average atomic mass or atomic mass of carbon? Well, you're going to use that percent in nature, and we are going to do that same process. We're going to put percent in nature here. and you're going to say, so our first thing we're going to look at is carbon-12. So the percent of carbon-12 in nature is 98.89% divided by 100%. Sometimes this percent in nature is also called percent abundance. So I'm going to put percent abundance in nature. And we are going to multiply that by the mass number for carbon-12. And the mass number for carbon-12 is 12. The mass is 12 AMUs for carbon-12. So we will multiply that and we will get a subtotal. And if you take 98.89 divided by 100 and you multiply that by 12, my subtotal is 11.8668. You want to keep all the numbers for average atomic mass. Don't round. Then you're going to get the percent abundance in nature of carbon-13. So 1.10% divided by 100% times the mass number of carbon-13, which is 13. And then you will do that calculation. 1.10 divided by 100 gives you 0.011. Multiply that by 13, and you get 0.143. And then the last one is you're going to take the percent abundance of carbon-14, which is 0.01%. You're going to divide that by the total abundance of 100% of carbon. And you're going to multiply that by the mass number 14. And when you do that, 0.01 divided by 100 gives you 0.0001. You multiply that by 14, and you get 0.0014. The last step is you are going to add all of these numbers together, all the subtotals together to give you a total. So I'm going to go backwards, 0.0014 plus 0.143 plus 11.8668, and I get 12.0112 AMU. Now, if you have a periodic table or look at a periodic table, which you might want to reference one now, you can see that this is the number. So I'll just give you what carbon looks like on the periodic table. Here's carbon. It has 6 up here. It's got 12.0112 down here. This number right here, this should be the same number on your periodic table down below. That is the average atomic mass of carbon's isotopes. This number up here is the number of protons, but this is the average atomic mass. Okay, let's try 2 more problems. Okay, gallium has 2 naturally occurring isotopes, gallium-69 with a mass of 68.9256 AMU. Now, because it gives you this very specific mass, I want you to use that instead of 69, but you can see it's very similar. And a natural abundance of 60.11%. Gallium-71 has a mass of 70.9247 AMUs and a natural abundance of 39.89%. Calculate the average atomic mass of gallium's 2 isotopes. So we're going to start off with the percent abundance, like always. And so we have 60.11% divided by 100% times, and so this corresponds to gallium-69, which has a mass of 68.9256 AMU. And gallium-71, its abundance is 39.89% divided by 100%. You're going to multiply that by its mass, which is 70.9247 AMU. And now we just calculate the subtotals and add. So here are my subtotals, 41.4311782 and 28.2918628. And then I'm going to add those together, and I'm going to get the average atomic mass of gallium. And what I would do for a rule for rounding for the final answer is to just go to the hundredths place. So this one is 69.72 AMU. That's fine. So I should have done that up here too. You can go to like 12.01 AMU. So let's go to one more problem. Boron has two naturally occurring isotopes, boron 10 and boron 11. The atomic mass of boron is 10.81. Which isotope is more abundant? So this problem is more of a thinking problem than a math problem. So you'd know if there was 50% of boron 10 in the world and 50% of boron 11 in the world, and those were the only two isotopes, well, the average of 10 and 11, if there's 50% of each, you'd have equal amounts of each, it would be 10.5, right? But the average atomic mass is not 10.5, it is 10.81. So now you have to think, which one of these isotopes is there more of? Is there more of boron 10 or is there more of boron 11? And if you think about it hard enough, you can think, wow, well, this number is closer to 11 than 10. So this percentage must be higher than 50%, and this percentage must be lower than 50% for boron 10 if the average atomic mass is 10.81. So which isotope is more abundant? The answer is boron 11 because this is closer to 11, which makes the average not right in the middle. It's closer to 11. There's more abundance of that.